this first problem, we are asked to find the surface area of this solid. It is comprised of two solids, a pyramid and a prism. So if we look at the prism, we have the lateral and one of its two bases on the outside. So the formula, which is usually pH plus 2 big B, we only need 1 because there's only one base shown. In addition to that, I need to take into account the pyramid. Well, the base is covered, so I need to worry about the lateral. So 1/2 PL. I don't need to worry about the bottom or the big B of this pyramid since it's hidden. Then I just go through and plug in what's missing. The perimeter of the base must be, well, the one I'm getting rid of, I'm going to count this one here. So the perimeter of this would be 40. The height of the whole figure would be 14. The area of that base, 10 times 10 is 100. Now onto the pyramid, the base is still 10 by 10, so 40. And the slant height is not given. So we need to find it by using the Pythagorean theorem. Well, that slant height is going to bisect this 10 to make it 5 and 5, so 13, 5, Pythagorean theorem will give us the slant height. That is a Pythagorean triple. It is 12. So running that through the calculations here, 14 times 4 is 56, add the 0, plus 100, half of 12 is 6, times that's 240, so 660 plus 240, and these two together, 900 inches squared. And there's the surface area of these two solids combined. Okay, for this next problem, finding the area or the surface area of this triangular prism. In a triangular prism, your bases must always be the parallel and congruent sides, which in this case will be triangles. There's our basic formula for surface area of any prism. Okay, so if this side is 10, this side is 10, so now you can figure out the perimeter of that base. So 10 plus 10 plus 5 is 25. The height of the entire prism is 20 feet. And now we need to do 2 times the area of the base, which is a triangle, so half base times height. Okay, now, if you look at this triangle, you must draw your altitude, or the height, down between the two congruent sides. So I can't draw it straight down here because 5 and 10 are not congruent. Can't go this side. I have to go this way. And the whole point of that is if it's drawn between two congruent sides, it bisects the base, or the side it intersects. So then it splits this into two congruent parts. So with that, you can now use the Pythagorean theorem. So 100 squared minus 2.5 squared, square root, it gives us our height. The square root of that answer will be the height, doing 100 minus the 2.5 squared, whatever that may be. And our base is where the 90-degree angle sits, in this case the 5. So this is going to be our setup that we're going to run through here. Well, this part's relatively easy here, 500. Half of the 2 cancels, so it's going to be 5 times the square root of 93.75. And running that through the calculator, 548.4 feet squared is the surface area. This next problem, we need to get the radius by itself to figure out what it is. So they give us the surface area and the height of this cylinder. The formula of a cylinder is 2 pi r h plus 2 pi r squared. So we're going to go through and substitute what we know. Okay, the first step in all of these types of problems is we're going to divide both sides by 2 pi. And by doing that, it cancels the 2 pi's over here and the pi over here, and then half of the 132. Half of 132 is 66. Equals what's left, so 5r plus this r squared. I have an r and an r squared, so you have to factor, set it equal to 0. I'm going to switch the order. To make this 0, you subtract 66, and now we can factor. Two numbers that multiply to give us negative 66, but add or subtract give us positive 5. So 11 and 6. That would be positive, this would be negative, which means r equals negative 11 or r equals positive 6. Radius length can't be negative, so 6 meters is the length of the radius for this cylinder.